Today is Tuesday, April 1st, but not really April Fool's, just April 1st. And today's lesson is on graphing polynomials number 2. You'll begin by doing a review ticket for our summative this Friday. Make sure you turn in your quiz corrections if you are retaking last Friday, March 28th's formative quiz. And you'll also be getting your homework out at the same time to check graphing polynomials number 1. Our learning target for today. Again, we are still going to be graphing polynomials, but this time we want you to use the number of zeros of a polynomial and the graphing calculator to identify the critical points to be able to graph. In order to do that, you will need to know how to find the degree of a polynomial and how to use the graphing calculator to identify critical points. You have to understand that single, double, and triple zeros give a certain shape to a graph. Of course, we'll explain that when we get there. And lastly, be able to graph a polynomial using those zeros and critical points. Just as a reminder, during this video, at any time you need to pause it to catch up. That's the intent, that you're doing this lesson at your own pace. So please feel free to pause at any time when you need a time to catch up, or perhaps you need to replay it to hear something again. Your bell work for today is the summative review quiz ticket number 1. Our quiz this week on Friday, April 4th, will cover imaginary numbers and the quadratic formula. So take a moment to complete the practice problems here on the ticket. Pause the video, hit play when you're ready to proceed. Okay, here's the answer key to the bell work. I'm going to zoom in very quickly. Okay, number 1, simplifying. The negative 5i on the outside. I took the negative from the inside here, pulled it out, so now I have negative 5i. The 27 then times 20 on the inside, prime factorize, pull out the pairs. Negative 30i times the square root of 15. Okay, let's move on to number 2. Scoot this up a bit. Okay, solving the quadratic using the quadratic formula. So maybe we need to sing the song. And I'm going to sing this song here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I know some of you just love my singing voice. So using the quadratic formula, you've identified the a value, the b value, and the c value, and you're just plugging it in. When it's all simplified, here's your answer right here. Okay, number 3, 2x squared minus 11x minus 21. My a value is 2, b value negative 11, and c value negative 21. Plug it into those spots in the quadratic formula right here. Simplify. Remember, when you take the square root, it's the positive and negative. So you have at the end 2 separate problems you're now solving. So x should equal 7 and negative 3/2. And remember, the solutions actually represent where that quadratic crosses the x-axis. In the last 2 problems, number 4 and number 5, be very careful. What we found a lot of people making mistakes on when we were solving these earlier is that people are forgetting this positive and negative square root. Make sure you remember that when you take the square root, it's a positive and negative. And because there's a negative on the inside, that means I pull an I out. That's imaginary. And then I have a positive and negative square root of 49, which is positive negative 7i. Number 5, when I take the square root, again, make sure it's the positive and negative. This negative right here comes out as I. Then I prime factorize 108, and I pull out my pairs here, multiplying 6 times I. So my final answer, positive negative 6i root 3. Okay, at this time we're going to correct your homework from Monday, which was yesterday, graphing polynomials number 1. Your homework was pages 32 through 34. Please be sure that you make corrections on your homework. Please don't just circle it or mark an X. You need to understand why you're getting something wrong. So as the answer key comes up, feel free to press pause to catch up and make any corrections on your homework. All right, so on page 32, graphing polynomials number 1, item number 1. So now we are looking at this one right here, the x to the 4th minus 25x squared plus 44. There are 3 terms. This is a trinomial, so you'd use your trinomial method for factoring. And when you get to here, you have 2 difference of squares that can be broken down again, x plus 3x minus 3 times x minus 4, x plus 4. This polynomial has a degree of 4, which means there are possible of 4 zeros. Find the zeros and plot them. That means you are solving each one of the factors up here that would make each one of those factors equal to 0. So 3, 0, negative 3, 0, 4, 0, and negative 4, 0. Now that we know our zeros, we can go ahead and plot them on the grid, which you will see my zeros plotted. There's negative 3, 0, negative 4, 0, negative 3, 0, 3, 0, and 4, 0 on the grid. Name and identify all critical points and plot them. Here you would have had to have used your graphing calculator, and on the graphing calculator I have an absolute minimum, two absolute minimums, which are down here, and a relative maximum of 0, 144. Okay, and that's that center point right here. So those points were then plotted. The y-intercept would be 0, 144. I also know that because of standard form up here. That is my y-intercept. And now I just need to describe the behavior. Okay, so the function is decreasing between negative infinity and negative 3.5. Then increases from negative 3.5 to 0, decreases between 0 and positive 3.5, and increases from 3.5 to positive infinity. Okay, number 2 has 4 terms. What factoring method would I use? I could use reverse distributing, or you could call it grouping if you're going to put them in the box here and work your way out. Then when I get this one over here, x squared minus 4, that's a difference of squares, so I can break it down into x minus 2, x plus 2. So now I have 3 factors, which means I have 3 zeros. Let's move on to the next page to continue. Okay, so as we just saw, that polynomial would have a degree of 3 with 3 possible zeros. And we found the zeros, negative 7, 0, 2, 0, and negative 2, 0, and plotted them over here on the grid. I used my graphing calculator to find my relative maximum and my relative minimums, which are right here. And the y-intercept I got from standard form back on the page prior to at 0, negative 28, which is down here. So notice when I graphed it, I had to change the scale on my grid. So this is no longer y values of 10 to negative 10. It's now 50 to negative 50, which means each line is worth 5. So then I describe my behavior, which is increasing between negative infinity and negative 4.9, decreasing from negative 4.9 to 0.27, increasing from 0.27 to positive infinity. Okay, item number 3, x to the 3rd minus 125. There are 2 terms. We're going to use a difference of cubes because both of those are cube numbers and they're subtracted. So here would be my factored form, x minus 5 times x squared plus 5x plus 25. Remember that this factor here is not factorable. It's a quadratic, it is a trinomial, but that is not factorable, which means it's a quadratic that doesn't cross the x-axis. So this this binomial from up here has a degree of 3, which means it has a maximum of 3 zeros. The only 0 it actually has, though, is from this factor here. So it's 5, 0. Go ahead and plot 5, 0. And this particular graph has an inflection point. And I know this all the way back from family of functions. This is just a cubic shifted down 125. So I'm just going from the origin down 125 and plotting it using my pattern of points. But because I had to change my scale here, you really can't see the 3 points that I plotted right there because they'd be all squishy together. My y-intercept I got from the standard form up here, which is -125. So graphing the polynomial, as you can see, I've got my 2 points plotted. My behavior is just from negative to positive infinity. Okay, here we are, number 4. We have x to the 4th minus 81 to factor it. Well, that is a difference of squares, and then another difference of squares evolves from x squared minus 9. So our correct answer would be B. Okay, B right here. What is the degree and maximum number of zeros? Okay, so this function up here has a degree of 4, which means it has 4 possible zeros. To find the zeros and plot them, that means I have to solve x minus 3, x plus 3, which is 3, 0, and negative 3, 0. Identify all the critical points and plot them. So I used my graphing calculator to make sure that there was no other critical points, but it would be an absolute minimum, which also happens to be the y-intercept down here. And then I put my zeros on there already, and it's just a quadratic. And the behavior decreases from negative infinity to 0 and increases 0 to positive infinity. Okay, now we have some multiplying monomials simplifying. So right here we have 2 monomials being multiplied. So I'm going to multiply 6 times 25 to get the 150, and then I add this stupid thing. Having a hard time writing on here. Add the exponents. So I have an x to the 1st, x to the 4th, which makes it x to the 5th. 2 and 5 gives me 7. And for z, it's 3 plus 6, which is 9. Number 6 here is x minus 4 to the 4th power, which means I have 4 x minus 4s. So if I multiply an x minus 4 times an x minus 4, I'm going to get x squared minus 8x plus 6. But I'm going to have 2 of those, which is why I put 1 up top and 1 along the side here. I filled in my box, and I got to move this over so you can see my final answer. X to the 4th minus 16x to the 3rd plus 96x squared minus 256x plus 256. Okay, we are now moving on to graphing polynomials number 2 using our notes pages in our binder of page 35 to 37. You are also going to need your graphing calculator to do these. All right, so let's get started. So we have this polynomial right here. Let me get my pointer out. There we go. So here's my polynomial, x plus 1 squared multiplied by x minus 3. So I have to put it in standard form of the polynomial, which means I have x plus 1 times x plus 1 times x minus 3. So if I were to write that out, x plus 1 times x plus 1 times x minus 3. So I could double distribute the x plus 1 times x plus 1, then multiply it again by x minus 3, which would be right here. So you'd have, whoops, let me go back to my pen. You'd have one of these boxes here that you had to fill in order to get this final standard form, whoops, of, I want the arrow. Well, let me grab the arrow. Anyway, x to the 3rd minus x squared minus 5x minus 3. So all we were doing was distributing in order to get the standard form. Now all of a sudden I have 2 arrows. Isn't that nice? Okay, so what is the degree of this polynomial? Well, in standard form, I can see that the highest degree would be a degree of 3. So that means my polynomial has a degree of 3 with a maximum possible of 3 zeros. Now here's the new part for today. We have what's called single zeros, double zeros, and triple zeros. Well, this first one here, and I'm going to circle it, that's what we call a double zero. There's 2 of them right here. So we have a double zero at negative 1, 0. And since I only have one x minus 3, we call that a single. All right, so to find our critical points, I just put the function back from up here into my graphing calculator and found my relative minimum, relative maximum. And of course, I'd want to plot those on my grid as well. The y-intercept I would get from standard form, which would be -3. And then all of these points you then end up plotting. So let's see what the graph might look like. Okay, so using all the points that I found, my 0, -3 y-intercept, I had a double 0 at -1 and a single at +3. Then down here, this point here was my relative minimum and another relative minimum. So I used those points that I found earlier and plotted all of them. So let's define what we see as a single, double, and triple zero, what that actually means. So a single zero means that the polynomial is a linear at the x-axis. That means there's a 1 in its exponent, like we saw above. So for example, that would be like x minus 3. Now a double zero means it is a quadratic, which makes sense, raised to the second power, quadratic at the x-axis. The key word here would be at. So that would be like a 2, whoops, let me grab my pen there. That would be like a 2, come on, in the exponent. For example, like we saw above, x plus 1 squared. So we're looking right here at that 2. That tells me it's a quadratic at the x-axis. And if you couldn't guess already, a triple zero is a cubic at the x-axis. So that means it kind of plateaus. It's our inflection point. But it's right there on the x-axis. And it would be a 3 as your exponent. So for example, if I had x minus 4 to the third power. All right, so let's try an example together. So example number 2 on page 36 is negative x plus 2 to the third power minus 4. Okay, so writing this in standard form, I'm going to have to blow this up so I have more room to write because it'll take a few minutes here. All right, so I have negative, whoops, that didn't work. Here we go. Negative x plus 2, x plus 2, x plus 2, and then minus 4. So before I even continue to change it to standard form, I really can identify that I have a triple zero. Okay, so we'll talk about that in just a moment. So let's go ahead and, let's factor this out. So I like to distribute that negative to my first term. So negative x minus 2 times x plus 2 times x plus 2 minus 4. I'm going to have a box here with negative x minus 2 and x plus 2. And I'll fill in the box with negative x squared minus 2x minus 2x minus 4. And I know that I'm going to combine those like terms and turn that into a trinomial, which I'm going to put at the top of this one. So that becomes negative x squared minus 4x minus 4, and I still have another x plus 2 to use. So I end up with negative x to the third minus 4x squared minus 4x minus 2x squared minus 8x minus 8. Now I need to combine my like terms. Okay, now once I have filled in the box, I can't forget that I had this minus 4 out here. So I'm going to put this minus 4 right here Then I need to combine like terms to then simplify and put it in standard form. So my final standard form would be negative x to the third minus 6x squared minus 12x and minus 12. This step right here is probably going to be where most people will forget to do, and that's really important because that's your y-intercept. So right here is my y-intercept. Now that I have the function in standard form, I know that this polynomial has a degree of 3. So a degree of 3, that means I have a possible maximum number of zeros as being 3, or in other words, 3 x-intercepts. I'm going to wait to find the x-intercept right here on the next page using my graphing calculator. I'll show you that in a minute. And because I know this is a cubic, this is going to have an inflection point. And I know that this particular function, back from family of functions, is a cubic that was shifted left 2, down 4, and flipped. So my critical point is an inflection point then on negative 2, negative 4. And the y-intercept then is 0, negative 12. So I would then go ahead and plot all these points, and then I would graph it. So I am going to stop here and go to the next page and walk you through how I use the calculator to help me with all of these steps. Okay, so let's go ahead and graph this polynomial. Using our translation methods, we're going to go left 2, down 4, and flip it. So left 2, down 4, and flipping it. So there's my pattern of points there. So 1, 2, 3, 4, 5, 6, 7, 8 over 1. And I know that I had a negative 12 down here as my y-intercept. So I'm just kind of sketching using some of those major points that I already knew. Now, how can I use the calculator to check all my work? So first of all, let's get the graphing calculator out and go to the home screen. Once you've landed on the home screen, you need to select a new graph or go to your graphing scratch pad, and you're going to enter in the function into the calculator just like we had it, and you'd hit enter. So this is what's going to appear on your screen is this graph right here. You can see the inflection point is right there. Okay, so let's see what we would do next. Next, we're going to take and go to the table. So to go to the table, we would hit Control T, and I'm just going to the table to verify that my y-intercept is 0, negative 12. So when x is 0, y is negative 12. That just verified that I double distributed or triple distributed to get the right y-intercept. Okay, so next what I would do is then let's analyze the graph and let's find that 0. So you'd hit Menu, Analyze Graph, go over to the 0. Okay, and then once the next screen pops up, oh, where did it go? Let me see what happened to that slide. All right, here we go. So once you analyze the graph, you want to select 0. You move your cursor so that you have that x-intercept there in the window. And we find that we have a 0 at negative 3.587, or in other words, negative 3.59. So if I were to write that in on the graph, that would be right here at negative 3.590. So then this x-intercept goes up to on item number D right here. You would write it in up there. Okay, here we are on example number 3, and we have negative x plus 3 squared times x minus 2. So in order to give that in standard form, again, we have to do all this distributing. So let's go ahead and do that. We have negative x plus 3 times x plus 3 times x minus 2. And I like to distribute right away so I don't forget. Negative x minus 3, x plus 2, whoops, x plus 3 there, and then x minus 2. So I am going to double distribute here and put my negative x minus 3 and my x. My pen got off there, x plus 3. So then let's go ahead and fill in the box. Negative x squared minus 2x minus 3x, and that would be minus 9. And I'm going to have to double distribute again. So now I'm going to put my x minus 2 down here. And my new trinomial that I got inside the box here, I'm going to put on the top. So negative x squared. Negative x squared, this is minus 6x and minus 9. Now we need to fill in the box here. Negative x to the third minus 6x squared minus 9x. And that's an x right there. And then I have 2x squared, 12x, and 18. Now I just need to combine like terms to write my simplified answer. So we get negative x to the third minus 4x squared plus 3x plus 18. So that means I have a degree of 3 with a maximum number of zeros of 3. Okay, now here's the new part. I now have a double x-intercept at negative 3, 0, and a single at 2, 0. And I know I'm going to have a relative maximum only because I've graphed it on my calculator, but I'll come back to that one momentarily. The y-intercept is going to be 0, 18. I got that from my standard form. And now it's time to graph the polynomial, and I'm going to go on to the next page to do that. Okay, so I need to go ahead and graph then my double 0 at negative 3, which is right here, and my single at 2, 0, which means this is going to be a quadratic that touches the x-axis at negative 3 and a linear that's going to go through 2, 0. My y-intercept is 0, 18, so I'm going to put my 18 up here, which means this has a scale of 20 up top. So I'm going to have something along this line here, something like that. But now I need to use my calculator to find out this critical point right here. So let me show you how I did that on my calculator. Okay, my first step was to go ahead and enter it into the calculator like you see right here. Okay, and I just entered the function back from the factored form that I have. And my next step was to then make sure I had the right y-intercept. So here it is, 0, 18. I hit Control-T to go to the table. Next, I needed to change my window because as you can see here, I can't see my top point that would be coming up right above here. So I need more y values, positive y's that is. So I changed my window so that I had a maximum of 25 in my y value. And by doing that, I then got the following graph. All right, so here's the graph that this window then gives me. But I can see my relative maximum, but I'm going to have to use my calculator to find that. So I'd go to Analyze Graph, select your maximum, and when you do that, you set your window, and then you find your maximum, which is 0.33 and 18.52. So that point up at the top that I've circled is 0.33, and I'm going to have to move this out of the way, 18.52. Okay, now I'm going to use this point to help write my behavior. So let's get on to that step next. Okay, I'm really going to be using, I'm going to be writing my behavior for this letter H down here. Because I don't have a whole lot of room underneath here, I'm going to put it off to the side. So I'm going to move my screen here off to this side and write my behavior over there. Okay, so this function is decreasing from negative infinity to this point right here, which is negative 3. And then I put my x, decreasing, decreasing. Okay, then from negative 3 to this point here, which is 0.33, my graph is now increasing. So this was decreasing, then it increases, and then finally my graph decreases again from 0.33 to positive infinity. And there's my behavior. Okay, here we are at number 4, our last example that we're going to walk through together. First thing we need to do is put this into standard form. Okay, so what I've done to try and make things a little smoother here, because it's so hard to write on the screen, I took a picture of my answer key. So I double distributed x plus 2, x minus 4 to get this trinomial here of x squared minus 2x minus 8, which I then put at the top over here. And I brought this x plus 5 down here, filled in the box, so here's my standard form. So now from here I know that my degree is going to be 3 with a maximum number of zeros of 3. Okay, now I'm going to find my x-intercepts. I know that they are all singles, so I would have to go all the way back up. These here are all single zeros, and of negative 2, 4, and negative 5 would be my zeros. So that's how I'm getting my x-intercepts right here. And I said that was negative 2, 0, and 4, 0, and then negative 5, 0. And then, of course, I'd want to plot these then down on my graph at negative 2, 0, negative. Okay, and my other x-intercept was negative 5, 0, which would be right about here. And here's my positive 4, 0. Okay, my y-intercept is 0. Well, let me use blue. 0, negative 40. So I'm going to have to change the scale here on my grid, and I'll just go down to negative 100 and positive 100. This can still be 10, this can still be negative 10. So negative 40 would be right about this point here. Since these are all singles, I know that they're all going to just cross right through the x-axis. So let's go and use our calculator to find out our critical points. Okay, so I went ahead and I entered the function into the calculator, and this is what I got. Okay, so I have my my zeros that I already knew ahead of time, but I can't really see my relative maximum and minimum, so guess what? We have to change the window, and that would be this one. And get that one out of the way. So here's my window settings. I went from negative 10 to 10, negative to 100 to 100, like I showed you a few moments ago when I had my graph over here. This went down to negative 100, positive 100, 10, and negative 10. So I also want to make sure that I have the right x-intercept, so I also made sure that I went to the table to make sure that I have that intercept there of 0, negative 40, which I do. Put that aside too. Okay, but now in order to find my my critical points, I'm going to analyze graph and not find the 0, but I went down and I found maximum and minimum. So then after I did that, this is what I got in the end. So here are my critical points. So I have a relative maximum and a relative minimum. So at negative 3.65, 3.65, which is going to be really tight, up to 17. Oh, that's probably about here. I can't get it very good with a pen on this screen. 1.65 and negative 57. So we're looking maybe around here. So then when I draw in or just sketch it in, I'm looking something like this. Okay, so let's just go ahead and write these numbers in here. I'll just write in my x value so I can describe my behavior. This was negative 3.65. And this is a positive 1.65. Okay, now it's time to do our behavior. All right, so my function first increases, then decreases, and then increases again. And it increases from negative infinity, Oh, that's a bad infinity symbol. Let me redo that one. Okay, so from negative infinity to negative 3.65. Then from negative 3.65 to 1.65, and then 1.65 to positive infinity. Then I just have to add my symbols in here. And there's my behavior. Now you're set. Let's see how you do. So your homework is Graphing Polys number 2, pages 35 to 38. Good luck, and let's graph some polys.